Hello there, and welcome. I'm glad you found your way here. Maybe you've had one of those long days that felt like wading through clouds, or maybe you're just the kind of person whose mind prefers to wander the cosmos before sleep. Either way, you're in the right place. You don't need to do anything now but rest. Let your body grow soft, your breath slow, and your thoughts loosen gently like leaves drifting in slow water. We're not in a hurry here, we're just floating. Tonight, we'll visit a world too vast to walk across, too distant to see clearly, but so massive it pulls at the threads of the entire solar system. Tonight, we drift toward the giant, Jupiter. It waits far beyond the asteroid belt, a swirling monarch of gas and storms. Some call it a planet, and it is indeed, but it's also more than that. It's a kind of solar landmark, a turning point in the deep architecture of space, a weight so immense it bends the orbits of comets, a shape so wide it could swallow over 1,000 Earths and still have room to spare. Jupiter doesn't just orbit the sun, it holds court. And tonight, we're invited to float closer, not with rockets or rovers, but with calm curiosity and the quiet kind of attention that only comes when the world outside has gone still. And while you're settling in, before your eyes grow too heavy, I'd love it if you gently tapped subscribe or pressed the little hype button YouTube recently added. It's a small click, but it helps keep these experiments and explorations orbiting out into the algorithm. You can also leave a comment telling me where you're listening from and what time it is in your corner of the night. It's oddly fascinating to see where people are drifting off with us, scattered across the world like stars across the galaxy. So take a deep breath, let your day drift away, and let's begin our journey. Jupiter is not a place with mountains or valleys. It has no solid ground to stand on. If you fell into it, you wouldn't hit a surface. You'd simply descend, sinking through clouds upon clouds, until the pressure and heat swallowed you whole. It's made mostly of hydrogen and helium, like the stars themselves. In fact, if it had been just a little larger, it could have become a star. A failed sun, some have called it. But that word, failed, feels wrong for something so successful at being exactly what it island. Not a star, not an Earth, not a quiet ice world. Something in between, something ancient, radiant, and spinning faster than any other planet in our system. A day on Jupiter is only about 10 hours long. That's how fast it rotates, whipping around on its axis, dragging bands of clouds into wide, striped currents. From afar, it looks like a marbled eye, layered with orange, brown, cream, and white. Those colors are gases, moving in parallel lines, each with its own speed and shape. Where they collide, storms blossom. Some last only hours. Others, like the Great Red Spot, have persisted for centuries. Imagine that. A storm older than any living thing on Earth. A wind with memory. We'll explore it soon, but not just yet. First, let's stay right here, drifting above the clouds, letting the soft spin of this enormous world lull us deeper into rest. You may not be able to see it from your window, but Jupiter is one of the brightest objects in our night sky. You've probably seen it before without realizing. A pale beacon rising slowly, moving through the constellations, always just a little too bright to be a star. Galileo saw it. So did Babylonian astronomers. The Romans gave it the name of their king of gods. And before all of them, somewhere on a hilltop or beside a fire, someone looked up at that same moving light and wondered what it might be. We still wonder, and that's part of what makes it beautiful. Science has brought us close, sent probes like Juno to orbit it, photographed its moons, listened to its magnetic hum. But wonder hasn't gone away. It's just changed shape. Tonight, that wonder will take the form of 100 stories, not rushed through or counted down, but gently unwrapped. We'll follow them like stepping stones scattered across a river of gas and gravity. Some of these facts will surprise you. Some may simply echo in your thoughts as you fade into dreams. We'll meet moons made of ice and fire, explore storms that could swallow continents, glide through rings made of dust, and dive into oceans that lie beneath frozen crusts. You'll hear about lightning that flashes in silence, magnetic fields that stretch wider than the sun, and particles that spiral invisibly around an invisible core. But for now, just one fact at a time. The first, Jupiter is old, very old. It formed not long after the sun itself, more than 4.5 billion years ago. In the swirling disk of gas and dust that once surrounded our newborn star, Jupiter was among the first to gather mass, sweeping up material with its enormous gravity, growing quickly until it became what it is now, a giant of giants. And because it formed early, it helped shape everything that came after. Without Jupiter, Earth might never have formed at all, or it might have been struck again and again by comets. Or maybe we would have simply drifted apart, like grains of dust in a solar wind. Another fact, Jupiter doesn't orbit alone. It's surrounded by a retinue of moons, over 90 of them now confirmed. Some are small and silent, mere rocks. Others, like Ganymede and Europa, are worlds in their own right. We'll visit them too, but not tonight. Tonight is just the beginning, and as you listen, you don't need to remember every detail. Let the facts wash over you like rain on a window. Let them settle where they will. Some may stay with you. Others may slip into the quiet space between waking and sleep. That's part of the journey. The giant is waiting, and so is the rest of the story. We'll see it together. One orbit, one moon, one glowing thread at a time. For now, rest easy. The clouds are thick and warm, and the wind hums low. We're drifting through Jupiter's sky, and the night is just beginning. If you were to float gently through space and come upon the planets of our solar system, one would rise before you like a colossus. Bigger than all the rest, heavier than everything nearby, turning slowly in deep, unhurried silence. Jupiter doesn't glow like the sun or shine with its own light, but its presence is unmistakable. You would feel it before you saw it, the way a mountain looms behind the fog. Not just a planet, but a gravitational force, massive, ancient, and still growing in mystery. Jupiter is the king of the planets, not because we called it so, but because the laws of physics do. It is, by far, the most massive object in the solar system, apart from the Sunday. If you took Earth, with all its mountains and oceans and iron core, and multiplied it 318 times, you would begin to approach Jupiter's mass, and even then, it would be only the beginning. You could take every other planet, Saturn, Uranus, Neptune, Mercury, Venus, Mars, and fold them neatly into Jupiter's volume, and there would still be space left inside. It could contain them all and ask for more. Yet for all this size, Jupiter has no surface. There is no ground to land on, no crust, no mountains, no plateaus or plains. If you descended into Jupiter, you would never land. You'd fall through layers of thickening atmosphere, from cream-colored cloud tops into deepening shades of orange and brown, through hydrogen gas into liquid hydrogen, and finally into a metallic sea formed not by earthly pressure, but by forces far stronger, forces that crush atoms and change the rules. Somewhere far below, there may be a core. It might be solid. It might not. We don't know. What we do know is that nothing survives the descent. Jupiter's weight shapes everything around it. Its gravity bends the paths of passing comets, redirects asteroids, and stabilizes the orbits of some moons while stealing others entirely. In the vast emptiness between the planets, Jupiter is like a lighthouse. But instead of casting beams of light, it casts a field of influence, tugging gently at the rest of the solar system. Without it, the architecture of our cosmic home might look entirely different. There may have been no Earth, or too many Earths. no safe path for the moon, no quiet corner for life to settle and grow. Astronomers call Jupiter the solar system's vacuum cleaner, not because it pulls in dust or debris, but because its enormous gravity acts as a shield, drawing in or deflecting countless comets and icy wanderers that might otherwise strike the inner planets. Some of these are pulled in directly, caught in its invisible net, and flung into its depths. Others are nudged away into wider orbits or shattered entirely. Jupiter doesn't just protect, it patrols. It has been shaping trajectories for billions of years, sometimes violently, sometimes silently, but always persistently. Despite its bulk, Jupiter spins faster than any other planet. A full rotation takes just under 10 Earth hours. That rapid spin, combined with its fluid nature, causes the planet to bulge at the equator and flatten slightly at the poles. It's not a perfect sphere, but a flattened orb shaped by motion and momentum. Its outer atmosphere flows in massive bands, whipping around the planet in alternating streams. These bands move at different speeds and directions, creating immense jet streams and storms the size of continents. It is both massive and dynamic, weight and motion in delicate balance. Because of its size, Jupiter's gravitational pull extends far. It commands a family of moons, over 90 of them, some of which are worlds in their own right. It captures Trojans, asteroids that travel ahead and behind it in orbit, held steady in place by its gravity. Even some distant icy objects in the far reaches of the solar system owe their orbits to Jupiter's early influence. Its presence is stitched into the orbital DNA of everything nearby. It doesn't just orbit the Sunday, it helped choreograph the entire dance. And yet, for all this, Jupiter is not dense. In fact, it's less dense than Earth. It's made mostly of gas, hydrogen, and helium, like a star that never quite ignited. Its clouds form bands and zones, spinning with winds that roar at hundreds of kilometers per hour. Thunderstorms erupt deeper within. Lightning crackles across its night side, visible from orbit as silent flashes. Beneath all that, pressures rise until gas becomes liquid, and liquid becomes metallic. But still, no ground, just more gravity, just more depth. There is something paradoxical about Jupiter. It is massive, but light, dominant, but distant. It does not support life, yet may shelter the conditions for it on its moons. It is ancient, but still shaping what comes next. We imagine kings as towering above others, ruling from thrones, draped in robes of gold. Jupiter doesn't wear a crown. It wears clouds. It rules not by decree, but by inertia, by mass, by quiet, irresistible gravity. Even its name reaches deep into myth. Jupiter, in Roman lore, was the king of gods, the bringer of thunder, the wielder of storms. Not by accident did early astronomers give that name to the largest light in the night sky. They saw what we still see now, a world that is not just large, but lordly. A force you can't ignore, even from millions of kilometers away. They didn't know about mass, or hydrogen, or gravitational assist. But they knew power when they saw it, and so do we. Every spacecraft that travels through the outer solar system uses Jupiter's gravity like a slingshot. It bends their paths, speeds their travel, and hurls them towards Saturn, Uranus, or beyond. Even our machines rely on its pull. Even our metal and mathematics are not immune to the giant's reach. Tonight, we float near it. Not too close, just enough to feel the shadow of its weight. The way space curves slightly in its presence. The way everything around it seems to pause, just for a moment, and take notice. It does not demand attention. It draws it, naturally, like tides pulled by a distant moon. We are drifting beside a giant, not just a planet, but a pillar of our solar system. A shape that holds stories in its storms, moons in its embrace, and a quiet gravity that echoes across billions of years. It does not need to move toward us. It is already here. It has always been. Deep in the southern hemisphere of Jupiter, there is a storm that has never stopped. A swirling, blood-red vortex twice as wide as Earth, spinning and howling beneath the planet's clouded skies. We call it the Great Red Spot, though it's more than red and greater than just a spot. It's a monument of motion, a wound in the sky, a whirlpool the size of a world, and it's been there for as long as humans have been looking upward. The first recorded sighting of the storm may date back to the 1600s, drawn with trembling hands through early telescopes, its shifting shape captured in sketches long before we understood what we were seeing. Since then, it's never vanished. It has changed. It grown darker, shifted color, narrowed slightly, but it has never truly disappeared. While entire empires have risen and fallen, while centuries passed and stars were named and renamed, this storm continued to turn. It is older than the steam engine, older than the telescope that first revealed it. It has seen the entire arc of modern history, and still it spins. At its widest, the Great Red Spot stretched over 40 kilometers. That's enough to hold 3 Earths side by side, swallowed whole by a single Jovian tempest. Today, it's smaller, about 1 Earth across, but no less magnificent. Some scientists wonder if it's dying. Others believe it's simply changing, adapting, sinking deeper into Jupiter's atmosphere. The truth is, we don't know. We're watching it slowly shift shape and color, as if it were alive, as if it were listening. The storm rotates counterclockwise, completing 1 revolution every 6 Earth days. Inside it, winds scream at over 600 kilometers per hour, faster than the most violent hurricanes on Earth. But this isn't a hurricane. It doesn't drift across an ocean. It is the ocean. A sea of storm clouds suspended above a liquid sky, anchored by forces we can't touch, only measure. At its center, the winds slow. There's a kind of eye there, calm compared to the outer rim, but still wild compared to anything we know. If you could fly into it, you might find layers of gas tinted in shades of copper, coral, and rust. You might see lightning arcing like silent veins beneath the clouds, or vertical towers of ammonia and water vapor rising from deeper below. Flying through it wouldn't be like flying through anything here. There's no ground, no ocean, no mountain range to crash into. Just thicker and thicker air, denser and darker, the deeper you go. Temperatures rise. Pressure mounts. Visibility fades to nothing. You might hear the rush of hydrogen winds in your imagination, though in truth, you'd be long crushed by the weight before you reached anything resembling a center. But this is a dream, not a mission. In the quiet of the night, you're allowed to imagine the impossible. Surrounding the Great Red Spot are other storms, smaller but still monstrous. Jupiter's atmosphere is stacked with them, layered like a storm-filled symphony. White ovals, brown barges, twisted gyres that form, stretch, fade, and reform again. Some are born from the turbulent interactions between cloud bands, where opposing winds meet and curl. Others seem to rise out of nowhere, sudden and bright, like brushstrokes of energy flung across a fluid sky. And beneath them all, deeper still, the weather continues. We can't see it, but we know it's there. Storms beneath storms, wind beneath wind, heat building in silence. From a distance, Jupiter looks serene. Its pastel bands glide softly across its face, a planet-sized marble turning slowly in the night. But inside, it's chaos, it's motion. The largest weather system in the solar system is not on Earth. It's not even close. It's here, on a planet with no surface, no seasons, no end to its atmosphere. The Great Red Spot is just one piece of it, a landmark in an ocean of kinetic energy, a red eye that never sleeps. Its color, once a deep brick red, has faded over time. Some years, it turns pale orange. Other times, salmon pink. We don't fully know what causes the color. It may be complex chemical reactions triggered by ultraviolet light. It may be sulfur compounds or phosphorus, or something we haven't yet named. The Juno spacecraft has peered into it, measured its depth, even tasted its composition from orbit. But still, it keeps secrets. Still, it spins. The storm is shrinking, yes, but it's not vanishing. In fact, it may be merging with smaller storms, absorbing their mass and changing its boundaries. At times, we've seen it flare brighter, like something waking up. Other times, it seems to retreat, curl inward. It's hard to define the lifespan of something like this. We don't even know if it ever truly began. Perhaps it was always there. Perhaps Jupiter itself gave birth to it in the early days, when the solar system was still young and molten. Maybe it was a side effect of gravity and spin, or maybe it's something more. Some ancient, self-sustaining storm, older than understanding. Imagine standing above it, far above, looking down as it turns. The clouds would stretch beneath you like a living canvas. You might see shadows flicker in the storm's folds, or plumes of gas rising like fingers from its edges. You wouldn't hear anything. Not really. There's no sound in space. But you might feel it. Some deep, vibrating energy that radiates from a force that's been spinning longer than any weather ever has on Earth. And around it, Jupiter turns. The entire planet rotates in 10 hours, faster than any other planet. The rapid spin stretches and stabilizes the storm systems, giving the Great Red Spot the energy to persist. Without friction, without land, there's nothing to slow it, nothing to stop the winds from circling forever. It is, in some sense, a perfect storm, not because of its violence, but because of its permanence. Tonight, it still turns. While you rest, while your breath slows and your mind begins to drift, the red storm continues to spiral in the shadows of Jupiter's night. It does not end. It does not rest. It just keeps moving, patient and vast, a beacon of turbulence wrapped in silence. It waits there now, like it always has, turning slowly in the darkness. As we drift deeper into Jupiter's presence, past the familiar bands of cream and rust, past the storms that never stop spinning, we begin to wonder what lies at its heart. It's a question that has haunted astronomers and dreamers alike for centuries. What lies beneath the clouds? What waits below the great storms? On Earth, we know our center. We've mapped the crust, traced the mantle, measured the core, solid and searing. But Jupiter is not like Earth. It doesn't wear layers like a peeled fruit. It doesn't give up its secrets easily. Its center remains elusive, a mystery wrapped in pressure, gas, and theory. We know this much. Jupiter is not hollow. Its mass tells us that. But what form that mass takes, how it's arranged, and where the boundary between atmosphere and interior truly begins, that part is still uncertain. Dozens of models have been built, each trying to describe a world we cannot touch. Some propose a solid core, dense and rocky, buried deep within the gas giant like a hidden pearl. Others argue for a diffuse center, a core that once was solid but has since dissolved, spread out like ink in water under the unimaginable pressure of the planet above. And then there are those who wonder if Jupiter has any traditional core at all, if perhaps its interior is a slow transition from gas to liquid to something stranger. Stranger than fiction, in fact. Deeper than any probe has ever traveled. Deeper than pressure chambers or labs could replicate. The rules begin to bend. The gases that make up most of Jupiter, primarily hydrogen and helium, begin to behave in ways that defy everyday understanding. Under extreme pressure, hydrogen stops acting like a gas and begins to flow like a liquid. Deeper still, it becomes something entirely different. Liquid metallic hydrogen. It's not metal in the sense of coins or wires, and it's not liquid in the sense of water. It's an exotic, shimmering state that can conduct electricity like copper, but flow like molten glass. It may be the very thing that powers Jupiter's immense magnetic field, the largest of any planet, stretching millions of kilometers into space. Imagine this for a moment. Beneath the clouds, below the turbulence, through the churning storms and descending temperatures, you reach a place where atoms are pressed so tightly together that their electrons become detached. Where hydrogen, the lightest of elements, transforms into a glistening, silvery sea that moves like a tide in the dark. This is not just science, it's alchemy at planetary scale. A transformation born not from magic but from gravity. Jupiter's weight compresses its very building blocks until they reshape themselves entirely. And still, we don't know if there's something deeper. The core, if it exists, might be a mixture of ice and rock, squeezed into a superheated mush by the weight of the world above. It might be 20 times the mass of Earth, or it might have long since mixed into the layers surrounding it. It may be sharp-edged and small, or wide and wispy, like a fog made of iron. No mission has seen it. No instrument has measured it directly. We infer, we model, we guess. The Juno spacecraft, which has been orbiting Jupiter since 2016, was sent in part to help solve this mystery. It measures the planet's gravity field with exquisite precision, mapping tiny wobbles in Jupiter's spin, trying to read its mass like a doctor listening to a heartbeat. What it's found so far suggests complexity, not clarity. The core is not simple. It may be larger and more diffuse than expected. It may reach higher into the planet's interior than we thought. Or it may be shaped in a way we still don't fully grasp. And so, Jupiter remains a planet with an uncertain heart, a king with no crown jewel, or perhaps a crown jewel we cannot see. This ambiguity gives the planet a kind of poetic depth, a feeling that even in our age of data and distance, some things still refuse to be fully known. It reminds us that space is not just a place of answers, but a place of questions. Questions that sit patiently, waiting for us to grow quiet enough to ask them well. If you could travel there, into that heart, the descent would be surreal. You would pass through cloud after cloud, each thicker than the last. You'd fall through ammonia, through water vapor, through hydrogen so dense it glows faintly from the heat. The pressure would rise not like a wave, but like a wall. Every kilometer deeper would be another crushing step into a furnace that never flickers. And yet, no matter how far you fell, you'd never hit bottom. Not the way we understand it. You'd only sink further, into a place where weight is endless and light cannot reach. This is Jupiter's paradox. It is the heaviest of planets, yet it may not have a solid center. It commands the orbits of moons and comets, yet its own core slips through our instruments like a dream. We've mapped its magnetic fields, tracked its radio waves, watched its storms spin like dancers, but we still do not know what beats at its center. Perhaps we never will. Perhaps the beauty of Jupiter is not in what we can explain, but in what it holds back. Out here, in the silence of space, surrounded by rings of dust and light, Jupiter floats like a mystery in motion. Its heart may be made of iron and ice, or vapor and light, or something in between. Whatever it is, it keeps the planet alive, driving its fields, shaping its weather, anchoring its presence in the sky, a hidden engine humming in the dark. And so, we float a little closer, still wondering. The clouds curl gently above us, the wind passes soundlessly beneath, and somewhere far below, beneath layers of gas and time and pressure, the heart of the giant continues to pulse, unseen. If you were to look at Jupiter through a telescope, just a small one, nothing fancy, you'd see something extraordinary. Not just a pale dot in the sky, but a world wrapped in stripes, soft bands of color stretching from one edge to the other like brush strokes across a turning canvas. They're not painted on, and they're not still. They're alive. They shift, evolve, ripple. They form a pattern so iconic that even a child's drawing of Jupiter includes them. And yet, for all their familiarity, they remain beautifully complex, like ribbons of wind frozen in motion. These stripes, these bands, are part of what makes Jupiter unmistakable. They run horizontally, parallel to the planet's equator, alternating in tone: creamy whites, muted ochres, deep tans, and rusty reds. They aren't flat or uniform. Look long enough, and you'll see they swirl. They twist at the edges. They feed into each other. Some are smooth and broad. Others are turbulent, packed with storms and flickering shadows. They're not just decoration. They're the outermost expression of Jupiter's atmosphere, a language of wind and chemistry written across a planetary canvas. The lighter bands are called zones. They're generally cooler and higher in altitude, thick with ammonia ice that scatters sunlight and gives them their pale, milky color. The darker bands are called belts. These lie lower, are warmer, and may be stained with more complex molecules: sulfur, phosphorus, hydrocarbons, things we only partially understand. In some ways, Jupiter's clouds are like fog banks drifting over oceans of gas. In others, they're more like the surface of a storm-ridden sea, endlessly churning and never the same twice. What separates them? What keeps the bands from blending into a blurry mess are jet streams, massive, high-speed rivers of wind that flow in opposite directions along the borders of each zone and belt. These jet streams slice the atmosphere into sections, confining the clouds within their lanes, keeping them locked into those broad bands. The winds can reach speeds of over 500 kilometers per hour, faster than any weather system on Earth. And they never stop. Unlike our jet streams, which meander and fade with the seasons, Jupiter's are stable, powered by the planet's rapid rotation and deep internal heat. But here's where it gets even stranger. These bands don't all rotate at the same speed. The equatorial region of Jupiter spins slightly faster than the areas toward the poles. It's called differential rotation, and it's a side effect of the planet being made of gas rather than rock. There's no solid crust to keep the spin uniform. Different latitudes can rotate at their own pace, like independent belts on a massive conveyor. The result is that Jupiter doesn't rotate like a marble. It rotates more like a fluid, rippling and twisting even as it turns. Over time, the colors of the bands change, slowly, subtly, like the shifting hues of a distant sunset. A pale zone may darken. A dark belt may vanish altogether, only to return months or years later. Sometimes new features appear: white ovals, brown barges, sudden eruptions of bright material that stretch and spiral until they're caught by the jet streams and flung into long, curling trails. These changes aren't random. They're driven by storms, by internal upwellings, by deeper flows we can't yet see. But to the eye, they feel almost like breathing. Slow, deliberate, endlessly repeating. And yet, for all our data, all our images and spectrometers and flybys, we still don't fully know why the bands exist in such perfect regularity. We understand the mechanics, how rotation and convection drive the flows. But why those flows organize into these persistent stripes, so wide and clean and well-spaced, is still a question. Earth has jet streams too, but they don't carve the sky into ribbons. Saturn has bands, but they're more subdued, more blended. Jupiter's are bold, graphic, defined. It's as though the planet insists on being known, not just by its mass or its storms, but by its patterns, by the quiet order it maintains in the midst of chaos. You might wonder what it would be like to fly through those bands, to drift slowly over the boundary between a zone and a belt. You'd see the clouds beneath you shifting in color, the atmosphere rippling like a great painted river. From a distance, the bands appear stable, almost calm, but up close, they're anything but. Towering clouds rise like thunderheads, hundreds of kilometers high. Storms spiral into one another, dragging wisps of material behind them. Shadows flicker and pulse. Everything is moving, sculpted by wind, heat, and time. And all of it is suspended, floating. No mountains, no valleys, just atmosphere above and atmosphere below, stretching downward until light and color give way to pressure and heat. Jupiter's bands are the visible skin of a world that doesn't stop at the surface, because there is no surface, only depth. They are the topmost layer of a planet built from layers, each deeper and stranger than the last. In a way, the bands are more than meteorological features. They are the planet's memory. Each stripe holds the record of countless storms, chemical changes, and seasonal shifts. They are shaped by events we've seen and by those we've missed. They are living archives, constantly rewritten by invisible hands. And still, they turn. Jupiter spins every 10 hours, and with it, the bands rotate, slowly at the poles, faster at the equator, like gears in an ancient whispering machine. When we watch Jupiter, we're watching not just a planet, but a process, a painting that repaints itself endlessly, stroke by stroke, band by band. Tonight, as you drift beneath your own soft blankets, the bands of Jupiter drift above its core, silent, ceaseless, striped by forces that began billions of years ago. They do not stop to be seen. They simply are, spinning in place, part of a portrait only the universe could create. On Jupiter, lightning isn't just a flicker in the sky. It's something deeper, older, stranger. It's not bound to the rules we know from Earth, not confined to the quiet drama of summer storms or the electric tension of passing clouds. It is vast, monumental. A flash that stretches for hundreds of kilometers, a silent war between layers of clouds so thick and turbulent that we can't even be sure where they begin. It is power painted in electric strokes, sculpting light across a canvas of gas and shadow. The Voyager spacecraft were the first to catch glimpses of this alien lightning, not in photographs, but in whispers. Radio waves chirping softly through the vacuum. Each burst a signal, a reminder that storms were raging beneath the clouds, too far and too fierce to see directly. Later, the Galileo probe would confirm it visually, capturing sparks in the dark just beyond Jupiter's limb. And now, with Juno circling the planet in long, looping orbits, we've seen more. Bright, branching forks of light piercing the clouds like shattered glass, flashes that dwarf anything seen on Earth. Some of Jupiter's lightning is more than 10 times as powerful as a typical bolt from an Earth storm. That means more energy, more heat, and a larger region of sky torn open by a surge of charged particles. The conditions required to create such lightning are intense. Deep below the familiar bands and spots, in layers where water exists not as mist or rain, but as towering thunderclouds taller than Mount Everest, collisions between ice particles and liquid droplets build up electrical charge, just like on Earth, but magnified, thickened by gravity, and compressed by pressure. The weight of the atmosphere squeezes those clouds tighter, feeds them more energy, pushes them into conflict. Thunder rolls there too, though we can't hear it from here. It would be lower, slower, stretched out through the dense atmosphere. A growl, more than a crack. A sound that doesn't echo so much as sink. But even if we can't hear it, we know it's there. Juno's instruments have picked up the telltale signs. Bursts of radio energy, patterns of electromagnetic pulse that follow the flashes. It's thunder in a sky we can only imagine, a reminder that storms are universal, even in alien skies. But there's something curious about where the lightning appears. On Earth, we see the most powerful strikes in the tropics, near the equator, where warm air rises with the greatest energy. But Jupiter's brightest bolts have been seen near the poles. That wasn't expected. It suggests that something unusual is happening in the planet's interior. Perhaps heat is escaping more freely at the poles, Or perhaps the atmosphere there is shaped by magnetism in ways we don't fully understand. Either way, the lightning tells a story. A story not just of weather, but of internal energy, of heat and motion that begins far below, rising through layers of metallic hydrogen, carrying power upward until it breaks through the clouds. Some scientists believe that studying Jovian lightning might help us unlock the planet's secrets by analyzing the flashes, where they happen, how bright they are, how often they come. We can map the deep dynamics of the planet's interior. Lightning becomes a probe, an accidental messenger from beneath the surface, each bolt a flare from a hidden engine, revealing more about what churns in the planet's unseen depths. And still, there's a beauty to it, a poetic violence. These are not the dainty flickers of distant summer storms. They are eruptions of light in a realm where everything is large, slow, and silent. Imagine it for a moment, floating above the clouds, watching a horizon split open in a branching fork of cold fire. No sound, no rumble, just illumination. Bright, sudden, vanishing. The clouds flicker like a candle behind a curtain. Shadows ripple. Then it's gone, and the storm continues, whispering in pressure and color. These lightning strikes don't happen randomly. They cluster around massive storms, within belts of deep convection, where clouds roll like boiling oceans. Some of them may last for hours or days, not in a continuous flash, but in a cycle, a pulse. Lightning is heartbeat, storm is breath. Jupiter breathes in through its clouds, exhales with a flash. The cycle continues. At times, the storms themselves seem to dance with the lightning. Juno has captured massive cyclones near the poles. Entire systems of swirling clouds, each one larger than Texas, locked into a strange orbital ballet. And within those rotating towers of gas, lightning flickers. Not chaotic, but rhythmic. Not wild, but patterned. There's a logic to the madness, a symmetry in the fury. Jupiter's storms don't simply rage, they compose, they orchestrate, and in that composition, lightning plays its role. It sketches invisible shapes across the dark. It draws power from the unseen and returns it in a flare. It reminds us that this planet, so huge, so ancient, is not quiet. Not really. Even when it looks still, even when it floats silently in the sky like a marble caught in slow motion, it is charged. It is alive with weather. And sometimes it speaks in flashes. To the naked eye from Earth, we can't see the lightning. The distance is too great, the clouds too thick. But it's happening, right now, even as you listen. Lightning larger than continents, brighter than cities, striking through layers of cloud that stretch deeper than any sky we've ever flown. Somewhere above those flashes, Juno circles, watching, listening, sending back the echoes of storms in a tongue we're just beginning to translate. And tonight, as you close your eyes, as the world around you softens into quiet, remember that far away, across the solar system, lightning is sculpting its electric signature into the clouds of Jupiter. It doesn't ask to be seen. It doesn't need an audience. It burns in silence, in strength, in cycles. The sky tears, then heals. The light comes, then fades. And the storm continues. Jupiter doesn't travel alone. It is a monarch, yes, but one surrounded by a vast and varied court, each member orbiting in quiet homage. Over 90 confirmed moons encircle the planet now, and perhaps even more wait to be discovered, tucked into the darkness, like whispers lost behind a curtain. Together, they make up something more than a moon system. They are a miniature solar system of their own, diverse, dynamic, and ancient. They do not merely follow Jupiter. They dance around it, pulled into strange rhythms by gravity and time. Some of these moons are giants in their own right. Ganymede, the largest, is even bigger than Mercury. Callisto is ancient and cratered like a relic from the birth of the planets. Europa, with its icy shell, hides an ocean deeper than all of Earth's combined. And then there's Io, restless and molten, scarred by volcanoes that erupt like fountains of flame into space. These are not distant, forgettable satellites. They are worlds, each one distinct, each one alive with motion, mystery, or memory. But beyond the four great Galilean moons, the ones first seen by Galileo through a simple telescope in the early 1600s, there are dozens more. Moons that are smaller, fainter, oddly shaped. Some drift in wide looping arcs, far from the planet's equator. Others have orbits that move backward, retrograde, defying the rotation of their king. These moons are misfits and captives, likely born elsewhere in the solar system and pulled in by Jupiter's immense gravity over millions or even billions of years. They arrived as wanderers and became prisoners, but in their capture, they found a new identity. Moons bound not by origin, but by orbit. Some are no bigger than mountains. Others are dark as charcoal, their surfaces unreflective, their shapes irregular and battered. They are fossils from the early solar system, fragments of rock and ice that never became planets, and still they orbit, quietly, like forgotten thoughts circling a giant mind. Scientists classify them in groups: Himalaya group, Ananke group, Karma group, named for patterns in their orbits, like families of comets turned inward. But names are just handles. What these moons represent is something larger, a record of gravitational influence, of cosmic capture and collision, of formation reshaped by time. And between them, between the giants and the fragments, are those strange middle children. Moons like Amalthea, red and oddly soft, with craters that sink deep into a body made not entirely of solid matter. Or Thebe, close to Jupiter, stretched by tides, its orbit grazing the edges of the planet's ring system. These moons, too, have their roles. They contribute dust. They pull on one another. They participate in invisible gravitational games that echo across space. Taken together, the moons of Jupiter are a narrative, a slow-motion story unfolding in orbits and impacts and ice. Some of them tell tales of creation, how gas giants gather mass and sculpt their surroundings. Others speak of destruction, of moons that shattered and reformed, of bodies broken by collisions and scattered like seeds into the dark. And a few, like Europa or Ganymede, hint at something even more profound: the possibility of life, hidden in oceans we cannot yet touch, warmed by tidal forces rather than sunlight, waiting in silence. The beauty of these moons is not only in their variety, but in the way they transform our understanding of what a planetary system can be. Jupiter doesn't just influence the space around it. It curates it. It shapes the orbits of comets, rearranges the paths of asteroids, and gathers moons like a collector gathers artifacts, each one unique, each one held in place by the invisible strings of gravity. Some of these moons have been there since the planet's birth, part of its formation, bound by shared origin. Others came later, drawn in by fate, held fast by mass and distance. The result is a kind of cosmic museum, curated not by intention but by physics, filled with objects that orbit and orbit, never still, never the same. Jupiter's moons are not decoration. They are participants. Io's volcanism helps charge Jupiter's magnetic field. Europa's icy plumes may feed particles into the system. Ganymede has its own magnetic field, rare among moons, interacting with Jupiter's like a nested set of magnets, each spinning inside the other. Even the smallest moons, those too dim to see from Earth, contribute dust and gravity, shaping rings, forming gaps, perturbing orbits in ways we're still learning to understand. And yet, for all their motion and mass, the moons exist in a kind of silence. From afar, they drift through the blackness, slowly turning, slowly traveling. Their paths are fixed by complex mathematics, but they appear serene, unhurried. They don't shine by themselves, but reflect the light of the distant sun, glinting like beads on invisible threads. Some pass into Jupiter's shadow and vanish, then emerge again, ghost-like and faint. Others never stray far from the planet's brightness, always caught in its glow. From the surface of one, if you could stand there, Jupiter would fill the sky. A swollen, banded god looming overhead, its gravity, like a heartbeat, always present. There's something deeply poetic about how these moons exist. They are tethered, but free, captured, but in motion. They orbit a planet that itself orbits a star, that star part of a galaxy, that galaxy one among billions. And yet, each moon has a story, a shape, a surface, a history. Some are marked by craters, others by lines and fractures. Some are smooth, some are rough. All are old, and all have survived. In the end, Jupiter's moons remind us that complexity doesn't require chaos, that even in the cold outer reaches of the solar system, order can emerge, structure can form, and stories can be told in stone and ice, written across orbits and shadows. Tonight, as you drift toward sleep, the moons of Jupiter drift too, carving paths around a giant, pulling on one another. Whispering across space, a quiet chorus of companions circling forever. Beneath the icy shell of Europa, an ocean waits in darkness. It doesn't glimmer with reflected sunlight, doesn't shimmer in shallow pools, doesn't ripple with winds or waves. Instead, it stretches, vast and unbroken, beneath a surface that is frozen and fractured, smooth in places, scarred in others, hiding everything below in silence. Europa looks quiet from the outside, almost too perfect. But deep beneath that stillness, there is motion, there is warmth, there is the endless, patient slosh of water around rock, and possibly, just possibly, the slow pulse of life. Europa is one of Jupiter's largest moons, a pale marble drifting in orbit like a thought on the edge of a dream. Its surface is covered in ice, bright and reflective, crisscrossed with long, dark lines, like veins or writing or maps that don't lead anywhere. These are fractures in the ice, marks of tension, reminders that the crust is not as still as it seems. It shifts, it groans, it bends under the tidal forces of Jupiter's gravity, pushed and pulled in a rhythm that repeats every orbit. That rhythmic, flexing, slow, invisible, unstoppable is what keeps the ocean beneath from freezing. Because Europa, for all its distance from the sun, is not cold at its core. The gravitational tug of Jupiter creates tidal heating, a friction born from flexing, a constant kneading that warms the moon from the inside. It's this internal heat that keeps the ocean liquid. And not just pockets of water, not scattered puddles beneath the ice, but an entire global sea, a world ocean, wrapped around the moon like a blanket beneath its frozen crust. Some scientists believe it may contain twice as much water as all of Earth's oceans combined. Imagine that for a moment. A world smaller than our moon, holding more water than our entire planet. Not on the surface, but beneath it, sealed away, untouched by sunlight, wrapped in pressure and darkness. It is not an easy place to reach. No spacecraft has yet drilled through that ice. No robot has swum in those waters. We know of the ocean's existence through careful measurements, through the way Europa's magnetic field shifts, through hints in its gravity, through the way the surface flexes and rebounds like a sheet of living glass. And yet, in that ocean, something remarkable may be waiting. Not cities or civilizations, not anything loud or obvious, but life. Simple, silent, alien life. If it exists, it likely thrives near hydrothermal vents on the seafloor, places where heat and minerals pour out of the moon's rocky interior, just as they do in Earth's deep oceans. On our planet, those vents are home to ecosystems that flourish without sunlight, Bacteria feed on chemicals. Tube worms grow tall. Strange creatures drift in warm plumes of water, indifferent to the surface world above. Europa's ocean could be the same. A cradle of life kept warm by rock and chemistry, unlit but not unliving. If that's true, it would change everything. Because it would mean life can emerge not just in temperate zones or green valleys, but in the cold, dark corners of the cosmos. It would mean biology is not a fluke of Earth, but a possibility written into the laws of physics themselves. The surface of Europa offers clues. Sometimes, plumes of water erupt from the ice, shooting hundreds of kilometers into space. We've seen them in silhouette against Jupiter's glow, thin geysers of vapor and salt, spewing from cracks like breath from a sleeping mouth. These plumes might carry material from the ocean below, offering a brief glimpse into what lies beneath. NASA's upcoming Europa Clipper mission is designed to fly through them, sampling the spray, tasting the chemistry of a world it cannot yet touch. And then there's the ice itself. Some regions seem newer, smoother, suggesting that fresh water has welled up from below, refrozen on the surface, erasing old craters and drawing new patterns. In places, the ice looks shattered, like a frozen sea that has broken and healed again and again. This is not a dead crust. It moves, it changes, it remembers. Europa has no atmosphere to speak of. No clouds, no wind, no rain. But in its silence, it speaks of the deep. And in that deep, the rules we know may not apply. We don't know how thick the ice island. Some estimates say a few kilometers. Others suggest 20 or more. We don't know how salty the ocean is, or how much heat rises from the core. We don't know if life has ever stirred in its depths. But we are listening. There are instruments now, orbiting other worlds, trained toward Europa, watching and waiting, listening for radio waves, for chemical hints, for the soft fingerprint of something unexpected. And someday soon, there will be machines that fly closer, that skim the surface, that drop landers or drills or probes into the unknown. They will not see much. There are no cities to photograph, no forests to capture in color, but perhaps they'll taste the water. Perhaps they'll catch a molecule that shouldn't be there, or a pattern in the chemistry that feels deliberate, a whisper beneath the ice. In the meantime, Europa spins. It circles Jupiter like a careful dancer, always showing the same face, always turning in rhythm with its parent planet. Its nights are long, its days are bright but cold, and beneath it all, the ocean moves, untouched, unseen, older than any life on Earth. There's something haunting about that kind of waiting. A world wrapped in ice, cradling a secret, holding it close for billions of years, not hiding it exactly, but not revealing it either. Just existing, as it always has, as it still does tonight. A moon that looks quiet, but might not be alone. As you drift into sleep, imagine that hidden ocean, dark and deep and endless. Imagine the pressure, the silence, the slow swirling of currents that have never felt the pull of the moon or the breath of air. Imagine life, small, strange, surviving. And imagine that one day we'll hear it. A signal, a shape, a shimmer in the data. Not a shout, just a whisper. Ganymede is not just a moon. It is a world, heavy with secrets, cloaked in ice, and humming with invisible currents. At first glance, it may not strike you as dramatic. It lacks the violent volcanic fury of Io, the smooth mystery of Europa, or the craggy silence of Callisto. But look again. Lurking beneath that faded exterior is something monumental. A moon so large it outclasses an entire planet, a body whose silent heart generates a magnetic field of its own, a presence that defies expectation in every way that matters. It's easy to forget that moons can be worlds. We call them satellites, companions, secondary. But Ganymede is larger than Mercury, wider than Pluto, and heavier than it appears. Its gravity could hold an atmosphere, if only it had the right ingredients. Its mass bends light and tugs softly at Jupiter's rings. If it orbited the Sun on its own, we might have called it a planet without a second thought. But Ganymede doesn't follow the Sun directly. It orbits Jupiter, locked in step with a rhythm that includes Io and Europa, three moons caught in a gravitational dance that keeps them in constant motion, always pulling, always responding. But what makes Ganymede truly unique isn't just its size. It's the fact that it has a magnetic field. No other moon in the solar system does. Not even Titan, not even our own moon. Only Ganymede generates a field strong enough to carve a bubble within Jupiter's enormous magnetosphere. A miniature magnetosphere of its own, nested like a whisper inside a roar. We don't fully understand how it works. The field hints at a partially liquid core, a churning metal ocean beneath layers of rock and ice. Somewhere in the depths, motion is creating electricity, and electricity is shaping space. The field isn't strong in human terms. You wouldn't feel it if you stood on the surface. But to Jupiter's swirling plasma, it's a wall, a boundary, a challenge. It pushes back against the wind of particles that stream from Jupiter's poles, forming auroras at Ganymede's own. That's right, auroras, not on a planet, but on a moon. A shimmering glow at the poles, stirred by invisible tides of energy, flickering in a sky that no human has yet seen firsthand. The terrain of Ganymede is as complex as its inner life. Parts of the surface are ancient, cratered, dark, remnants of a time when impacts were common and the solar system was still violent and new. But other regions are different. Grooved, ridged, marked with long, sweeping bands that run for hundreds of kilometers. These grooves are unlike anything on the Moon or Mars. They look almost tectonic, like the stretch marks of a world that once flexed and cracked, its icy skin pulled apart by internal forces we don't yet fully understand. Some theories suggest that the grooved terrain was formed by cryovolcanism, ice behaving like lava, flowing and freezing, reshaping the landscape. Others point to tidal heating, the same process that keeps Europa's ocean liquid, stretching and squishing Ganymede over time. Whatever the cause, the surface tells a story of change. Not fast, not dramatic, but relentless. A story of pressure, of silence under strain, of a world that shifted slowly, steadily over eons. And beneath that surface, there may be water. Not just pockets or puddles, but a global ocean like Europa's, hidden far below the ice. If it exists, it would be sandwiched between layers of ice, trapped between solid crust above and frozen mantle below. It wouldn't see the sky, it wouldn't feel the Sunday, but it would be warmed from within, stirred by the same tidal forces that shape Ganymede's orbit. A sea beneath a sea, a liquid heart inside a frozen shell. Could there be life in that buried ocean? The same question we ask of Europa lingers here, quieter, but just as compelling. The chemistry might be different, the pressure greater, the distance from the sun even more profound. But life, if it exists, doesn't care about what we expect. It thrives in heat and pressure. It finds a way where we least anticipate. If anything stirs in that ocean, it would be the oldest story in the universe retold again. Life in darkness, clinging to warmth, writing its own history beneath miles of ice. From afar, Ganymede looks modest, dull gray, with faint swirls and blotches. It doesn't dazzle like Europa or burn like Io, but appearances deceive. Ganymede holds more secrets than it shows. Its surface is a canvas layered with ancient scars and shifting plates. Its interior is a mystery wrapped in magnetism. And its orbit, its resonance with the other Galilean moons, tells of deep connections, of forces linking bodies across millions of kilometers. One day, we'll send probes there. More than just flybys, more than just glances. We'll orbit Ganymede itself, scan its field, map its surface in exquisite detail. Perhaps we'll drop landers. Perhaps we'll drill. And maybe, someday, We'll melt a tunnel through the ice and lower instruments into the sea below, listening for movement, looking for chemistry, hoping for something unexpected. Not noise, not spectacle, but life. Simple, steady, and strange. Tonight, Ganymede continues its orbit. It turns slowly beneath Jupiter's gaze, caught in the embrace of its gravity. Invisible field, pressed against invisible wind. It is quiet, but in its quiet, it is extraordinary. A moon, yes, but also a world. Out beyond the asteroid belt, past the quiet shimmer of Mars and the drifting paths of the outer planets, circles a moon that never sleeps. A world of fire, cracked open from within, its skin alive with heat, its breath sulfur and smoke. This is Io, Jupiter's innermost large moon, and it does not whisper like Europa or wait like Ganymede. It shouts, it burns. It lives in the language of eruption, lightning, and flow. Io is the most volcanically active place in the solar system, not just occasionally active, not like Earth with its trembling faults and scattered hot spots, but constantly, relentlessly erupting. Its surface is dotted with hundreds of volcanoes, some larger than any found on our own planet. Some rise like ancient temples, others open like wounds, belching lava so hot it glows in the infrared. From orbit, the moon seems to flicker with change. A volcano erupts, flows for days or weeks, then cools, only for another to awaken nearby, painting over the past with molten future. The cause of this restless energy lies in a deep and invisible tug-of-war. Io is locked in a gravitational battle with Jupiter and its sibling moons, Europa and Ganymede. Their combined pull stretches and squeezes Io's insides with every orbit. This is tidal heating, not unlike what keeps Europa's ocean from freezing, but turned up to an unbearable degree. Instead of warming an ocean, it boils the core. Instead of nurturing potential life, it fuels a planetary tantrum. The surface cracks, the ground heaves, and magma flows like blood through fractured stone. The lava here isn't always the kind we know. Some of it reaches temperatures far hotter than any eruption on Earth, erupting in broad, blistering waves across plains stained yellow, white, and black by sulfur compounds. Io's atmosphere, if you can call it that, is a thin, toxic haze made mostly of sulfur dioxide, occasionally thickened by volcanic plumes that rise hundreds of kilometers into the sky before falling back down like ash-colored snow. These plumes don't drift on the wind. There is no weather here. They arc and collapse in eerie silence, casting long shadows on a surface that is never quite still. In places, lava lakes sit exposed, their surfaces rippling gently, broken by bursts of gas or fresh fountains from below. The largest of these, Loki Patera, is bigger than Lake Ontario. It pulses with a strange rhythm, brightening and dimming every few months, as if the crust breaks and reforms in a slow world-scale heartbeat. Scientists watch it carefully, tracking every flicker like astronomers once watched the phases of the moon, trying to decode the rhythm of a world that seems to breathe fire. And yet, for all its violence, Io is not monstrous. It is beautiful. Its colors are unlike anything else in the solar system. A patchwork of reds, oranges, yellows, and greens, painted by sulfur in its many forms. Where one region is smooth and glassy, another is jagged, like cooled lightning. Where one crater fills with lava, another fills with ice, briefly, before the next eruption washes it away. It is a planet of contrast, fire within ice, fury wrapped in stillness. If you stood on the surface of Io, you would see Jupiter filling the sky, 25 times wider than the moon appears from Earth, cloaked in bands and storms, its great red spot drifting lazily above you like an ancient eye. The ground beneath your feet would tremble, not with footsteps or wind, but with the movements of magma and the flexing of stone. You might see a plume erupt in the distance, a tower of gas and ash rising silently into black space. There would be no air to carry the sound, only the quiet press of your own breath inside your helmet and the distant hum of your instruments trying to keep up. And yet, Io is no place for humans. No atmosphere to breathe, no water to drink, temperatures that swing wildly, and radiation from Jupiter's magnetic field that would cook a person in minutes. It is a place to study, not to settle, a place to observe, not to touch. But from afar, from the safety of spacecraft and data streams, we marvel, we map. We wonder what it's like for a world to be in constant motion, never allowed to rest. There is no record of Io before Galileo first saw it through his telescope in 1610. No myths that describe its fury, no ancient stories passed down through generations. But since we've begun to watch it, it has become its own kind of myth, an icon of geological rage, a symbol of what happens when nature is not held back, when pressure is not relieved, when heat builds and builds until the surface itself can no longer contain it. And maybe that's why it fascinates us, because Earth is filled with rules and cycles, with seasons and tectonics and the illusion of control. But Io is raw, unapologetic, a place where destruction and creation are one and the same. Every eruption wipes away a little of the past and writes a new line into the landscape. Every plume is both an ending and a beginning. Tonight, as you drift, picture that. A moon that doesn't sleep, a horizon that glows with lava, then vanishes into cold darkness, a ground that rumbles without sound, that cracks and shifts and heals only to break again, a heart that never cools. This is Io, not quiet, not calm, but alive in its own violent, beautiful way. Callisto is a world that does not whisper, erupt, or shimmer with auroras. It does not pulse like Europa or tremble like Io. It waits. It remembers. It has watched the solar system spin and swell, watched planets form and moons fracture, watched storms rage across Jupiter's surface like gods in argument. And through it all, Callisto has remained still. It is the outermost of the 4 Galilean moons, orbiting far enough from Jupiter to escape the constant tidal chaos that reshapes its siblings. And in that distance, it has found peace, but not emptiness. Callisto is old, perhaps the oldest surface in the solar system, and it wears its age like armor. Craters lie atop craters, stretching back billions of years. Every impact is a memory, and it has never forgotten a single one. There are no flowing ridges here, no shifting plates, no volcanic plains to smooth the scars. Instead, the terrain is an endless tapestry of circles and basins, of splashes frozen in time. Valhalla, the largest of these scars, stretches over 30 kilometers, a relic of some unimaginable impact that rang the moon like a bell. Around it, ripples of terrain fan out like waves across a frozen lake, never melting, never fading. Some scientists believe that had this impact struck just a little harder, Callisto might have shattered entirely. But it didn't. It held, and it remembers. Unlike Europa or Ganymede, Callisto's surface hasn't been resurfaced by internal activity. That's part of its mystery. For a long time we assumed it was dead inside, cold all the way through, a frozen shell with nothing beneath but stone and ice. But then, data from the Galileo spacecraft hinted at something unexpected. Magnetic readings that wobbled as the moon passed through Jupiter's field, the kind of wobble you might expect if a salty, conductive ocean lurked beneath the crust. Not warm, perhaps, not stirred by tides, but present, waiting. If that ocean exists, it lies buried beneath over 100 kilometers of rock-hard ice. It would be isolated, dark, and still. Unlike Europa's potentially restless seas, Callisto's would be a quiet abyss. No known vents, no visible cracks, just a slow, quiet pressure. But water is water, and in the universe, that means possibility. And that's what Callisto offers most of all. Possibility. not of motion or eruption, but of memory. It is a geological fossil, a snapshot of a time before Earth had continents, before the moon had cooled, before the gas giants had finished forming. Its surface tells the story of the solar system as it once was, and as it could have remained, a place not transformed by heat, but preserved by cold, a museum in orbit. If you were to stand on Callisto, you would see a sky filled with Jupiter's glow, more distant than from its sister moons, but still vast, still dominant. The surface beneath your feet would be ancient, layered with dust and ice, broken only by the shallow rims of craters filled with shadow. There would be no wind, no sound, no change. Just silence, interrupted only by your breath inside your suit and the soft crunch of boots on regolith that hasn't moved in eons. That silence would not be empty. It would be full of stories carved into stone, full of the memory of impacts, of heat that came and went, of comets that struck and split and vanished. Callisto does not erase, it collects. And in that collection, it becomes something no other moon can offer. A time capsule, not of a moment, but of an era. It's tempting to overlook Callisto. It does not glitter, it does not flare with activity, but in its stillness, it holds something the others do not. Stability, continuity. While the rest of the solar system spins in a dance of change, Callisto is the one who watches, the witness, the scribe. Some scientists have proposed that if we ever build a long-term base around Jupiter, Callisto might be the best candidate. Not because it's the most exciting, but because it's the safest. Far from the intense radiation belts of Jupiter, it offers a more forgiving environment. Its surface, though harsh and cold, is stable and predictable. And if there is water below, it might one day be accessible. It is a quiet platform from which to explore a louder world. But even if we never land there, Callisto speaks. It speaks in the language of age, of patience, of history layered one impact at a time. It reminds us that not all wonder comes from change. Some comes from endurance, from being the one who stays while others move, from being the stone at the center of the stream. Tonight, as the solar system turns, as storms swirl across Jupiter and Europa flexes with invisible tides, Callisto orbits at a calm remove. Its craters catch the faintest light, and its frozen shell holds secrets not of what is happening, but of what happened long ago. And in a universe that changes so quickly, there is something sacred about a place that remembers, a place that holds on. Callisto is not the loudest moon, it is not the brightest, but it is the oldest, and in that, it is wise. Far beyond the edges of Jupiter's roaring clouds, beyond the windswept storms and the mighty presence of its moons, something quiet spins, something subtle, so faint that you could look right at it and see nothing at all. No gleam, no glint, no shining arc across the stars. And yet, it's there. A ring system, delicate as a breath, encircling the most massive planet in the solar system, like a whisper around a shout. When most people think of rings in space, they picture Saturns, grand, luminous, elaborate. The kind you can see even with a small telescope from your backyard. But Jupiter's rings are not that. They are not obvious or loud. They are not visible to the casual glance. They are dust. Tiny particles floating in space, forming halos that slip through darkness like smoke through air. They were discovered not by ancient astronomers gazing up in awe, but by spacecraft, with sensors and images and careful calculations. It was 1979 when Voyager 1, racing past Jupiter on its way to the outer planets, turned back and saw something unexpected. A thin line of light caught in the angle of the sunday. Something the eye alone could not detect, but which the light refused to ignore. That sliver revealed the first clues of Jupiter's hidden adornment. The rings of Jupiter are not made of ice like Saturn's. They are forged from dust, microscopic grains born from impact, tiny collisions on small nearby moons. Metis, Adrastea, Amalthea throw particles into space. When a meteor strikes, even something barely larger than a pebble, it ejects material outward. And Jupiter's gravity, immense and absolute, gathers those fragments into patterns, into arcs, into rings. The result is a system so subtle, it vanishes in normal light. But point the right instruments at the right angle, and it begins to reveal itself. There are three main components: a torus-shaped halo close to the planet, a brighter main ring beyond that, and two faint gossamer rings farther out, fed by even smaller moons that barely cling to their orbits. The entire system spans tens of thousands of kilometers, yet remains so thin you could fly a spaceship through it and hardly notice. And still, they are real. What makes them fascinating is not just their presence, but their persistence. Jupiter is a brutal place. Its magnetic field is the strongest of any planet, its radiation intense enough to fry electronics in minutes. Its gravity tugs at everything, shaping orbits, shredding comets, pulling moons into resonance. And in the middle of this environment, something as fragile as dust holds its form, not by overpowering its surroundings, but by dancing with them. These rings are ephemeral. They shift, they fade. They are constantly replenished and constantly worn down. The particles spiral inward over time, lost to Jupiter's atmosphere. Others are pulled outward or knocked away. Without the moonlets feeding them, the rings would disappear in a matter of years. But the impacts continue. The cycle persists. And so the rings survive, not through strength, but through balance. They are easy to miss. Even up close, you must look carefully, tune your senses, filter out the glare. But once you see them, it's hard to forget they're there. Like breath on a window pane or footprints on fresh snow, they are delicate traces of motion in a universe that often seems to favor force. They remind us that not everything lasting must be large. If you could float near them, orbiting in the dark between Jupiter and its inner moons, you might barely perceive them at all. A dim haze, a faint flicker when sunlight catches just right. You could reach out your hand and nothing would fall into it. The dust is too sparse, the particles too fine. But over distance, over thousands of kilometers, they form something real, something visible, something shaped by gravity and silence. And they aren't alone. All the gas giants have rings, even Uranus, even Neptune. Saturn is just the showiest. But Jupiter's rings, in their softness and impermanence, tell a different kind of story. One of collision and recovery, of small forces accumulating, of moons wounded by space debris, and the slow, silent gathering of their dust into form. Each grain in those rings is a history, a moment of impact, a mark left by the universe, traveling now in endless circles. It is possible that some of those grains will eventually fall into Jupiter's atmosphere, spiral down through its clouds, and vanish. Others may drift outward and escape, but for a time they remain, suspended between gravity and light, neither gone nor held, but moving, always moving. There is something poetic in that, in the idea that even the largest planet in the solar system chooses not just to wear rings of might and brilliance, but to carry veils of dust, as if Jupiter, for all its power, understands the beauty of restraint, the elegance of what nearly goes unseen. Tonight, as you close your eyes and drift, imagine looking up at that faint ring in the distant dark. Imagine a place where silence spins dust into circles and gravity draws patterns no one sees. Imagine a moon struck by a lonely rock, throwing particles into space, never knowing that the debris will dance in formation for decades, for centuries, held in place by the very force that might have crushed it. Jupiter's rings do not shout, they do not glow, they do not demand attention, but they endure, thin, fragile and faint, but always circling, always there, just like a thought that refuses to fade. They move not in chaos, but in cadence. 3 moons, bound to Jupiter, tracing ellipses through the void, caught in a rhythm that has lasted longer than our species has dreamed of stars. Io, Europa, and Ganymede, the Galilean trio, locked in a gravitational song, playing out in silence, in shadows, and in time. Each orbit not just its planet, but each other, tugging gently and perpetually, like dancers following choreography too vast to learn and too perfect to forget. Ganymede orbits once for every 2 laps of Europa. Europa spins twice for every 4 turns of Io, 1 to 2 to 4. A mathematical rhythm stitched into the sky, as precise as the ticking of a clock, but sculpted not by gears or springs, by gravity. And not just the weight of one moon pulling on another, but the way their pulls align, reinforce, and repeat. It's not just movement, it's resonance, a harmony of motion written across millions of years. These aren't static bodies, drifting in peace. They are flexing, groaning, responding to tides more massive than oceans. With each pass, each approach, they stretch one another like breathing stone. Jupiter's gravity tugs at them all, but the resonance multiplies the effect. It doesn't let them settle. It won't let them freeze. Instead, it fuels them from the inside out. Io, closest to Jupiter, endures the greatest pull. Its orbit wobbles under the combined grip of Europa and Ganymede, never quite circular, never quite still. This imbalance means its insides churn with friction. Immense, constant friction. Heat builds, rock melts, volcanoes rise and explode. Lava fountains arc into black skies, freezing midair before falling to a landscape that never cools for long. Io is not simply geologically active, it is geologically alive. Its heart beating with tidal fire. Europa feels the rhythm too. Farther out, it doesn't crack open with flame, but instead shudders beneath an icy crust. That crust is fractured, crisscrossed, almost braided, as if the moon's surface is remembering every note of the dance it cannot stop. Beneath that ice, we believe an ocean churns, not frozen or still, but moving, salty, deep, perhaps warmed by vents, perhaps stirred by forces we barely understand, and perhaps, though we can't yet prove it, alive. Ganymede, larger still, joins the dance from the outer circle. It pulls at Europa, which pulls at Io, which in turn tugs back. Ganymede's surface is older, more grooved than shattered, but within it may lie another ocean, another secret. And, strangely, it alone among all moons carries a magnetic field of its own, hinting at internal motion, a slow churn of liquid iron or salt water beneath ancient ice. This trio is not a random grouping. They are the product of time, of slow captures and shifting orbits, of gravitational locks that snapped into place and deepened over epochs. The resonance keeps them stable but stirred. Without it, their paths would drift. Their energies would dissipate. Io might go cold. Europa's ocean might freeze to its core. But the resonance resists entropy. It sustains complexity. And in that tension, held like breath, is the possibility of transformation. Scientists call it the Laplace resonance. But that name, while useful, feels too clinical for something so elegant. This is not just a system, it is a pattern. A celestial rhythm that speaks of balance and motion and interconnectedness. These moons are not just companions, they are collaborators, partners in an endless, invisible ballet around their massive parent. Jupiter, for its part, watches impassively. It does not intervene or adjust. Its presence is enough. Its mass, its pull, the stage upon which the moons perform. It shapes the rhythm by existing, and the moons respond by dancing. The great planet is not just a gravitational anchor. It is a conductor, holding time steady while the music plays. From afar, with telescopes and spacecraft, we watch the dance unfold. We time the eclipses, measure the wobbles, trace the shadows as they sweep across Jupiter's face. And what we see, again and again, is order. Not the stillness of a statue, but the persistent, unyielding choreography of a living mechanism. It is as though the universe wrote a melody in the motion of moons and has been playing it ever since. This resonance, this silent score, does more than move worlds. It reminds us of something we often forget, that even in deep space, even across distances so vast they boggle our senses, there is coordination, structure, memory. Moons that might never touch, never share air or light, are nonetheless tied to one another, shaping and reshaping their destinies with every orbit. And it reminds us that complexity doesn't always arise from chaos. Sometimes it is carved from pattern, from repetition, from the quiet insistence of rhythm. Nature doesn't just explode, it composes. And sometimes it uses moons as its instruments. As you rest, you might picture them, those three spheres circling in darkness, never colliding, never straying, yet constantly changing one another. Their paths are old, but not tired. Their energy, drawn from gravity, is recycled, sustained. No single moon could have created what they are together. Their resonance is not a coincidence. It is a relationship. And in that relationship, there is warmth. Not the warmth of sunlight or fire, but of persistence, of connection. A warmth born of motion that never quite settles, of companionship that spans silence. Even here, among the coldest corners of space, harmony can survive, and it sings in circles. In the vast hush between planets, where the sunlight is thinner and time seems to stretch, a lone machine has been circling a giant. Since 2016, NASA's Juno spacecraft has been threading a slow spiral around Jupiter, quietly, carefully, rhythmically. Its eyes always open, its sensors always listening. It didn't land, and it won't stay forever. But in these fleeting years of observation, Juno has become something more than a visitor. It has become an interpreter of a world that speaks in gravity and magnetism, in light and radio waves. Juno's orbit is unlike most others. It doesn't skim equators or hover near moons. It dives from pole to pole in long elliptical arcs, spending much of its time far from the planet, then swooping in close, so close. Just above the cloud tops, racing past at nearly 210 kilometers per hour. Each pass lasts only hours. But in those hours, Juno gathers volumes of detail. Magnetic pulses, gravity gradients, spectral fingerprints of the atmosphere. It reads the invisible. It listens for the hidden. What Juno has found is both familiar and strange. It confirms what we thought we knew, and then adds shadows and depth we never expected. It showed us that Jupiter's magnetic field isn't just powerful, it's wildly asymmetrical, stronger in some places, oddly weaker in others, tilted, warped. It's not the neat bar magnet of textbooks. It's more like a shifting storm of invisible force, tangled and alive. And Juno has peered through the clouds, not with cameras, but with microwave instruments that sense heat and structure deep below the upper layers. It's discovered that the planet's iconic bands, the cream-colored zones, and the rust-toned belts, aren't just surface features. They extend deep into the planet's interior, thousands of kilometers down, shaped by rotating jets and internal flows we can't yet fully explain. Jupiter isn't just beautiful on the outside. It's layered, complex, and turbulent far beneath the clouds. Then, there are the images. Juno wasn't primarily a camera mission, but it carried one. Juno Cam, meant to engage the public, to help tell the story. What came back were not just pictures. They were paintings. Swirling cloudscapes, colored in pale blues and storm-swept ambers, revealed storms like curling brushstrokes on an infinite canvas. The poles, especially, were a surprise. Instead of blank whiteness or symmetrical structure, Juno found clusters of cyclones. Massive, persistent, rotating storms locked together in polygons. At the South Pole, 9 of them, circling a central vortex. At the north, a slightly different number. The shapes stay stable, but the details always change. They pulse, shift, evolve. Jupiter's poles, once unseen, now haunt the imagination. There's something oddly intimate about Juno. For all its instruments and precision, it feels more like an artist than a scientist. It doesn't just measure Jupiter, it frames it. It reveals a planet not as a cold object, but as a place. And each orbit is another brushstroke, another line in a story that has no final chapter. And yet, this intimacy is fleeting. Juno's orbit, designed to minimize radiation exposure, is not sustainable forever. The spacecraft ages. Its instruments degrade. Its fuel dwindles. Someday, perhaps not far from now, it will be guided into Jupiter itself, to burn up in the atmosphere, to join the planet it studied. A poetic end, a return to the clouds, a final data point wrapped in flame. But until then, it circles, steadily, silently, gathering gravity data to map the planet's interior, revealing how mass is distributed beneath the storm, measuring slight wobbles to infer what lies at the core. Watching the auroras, those ghostly rings of light dancing near the poles, sparked by particles flung along magnetic fields, invisible from Earth but brilliant in ultraviolet eyes. Juno watches and listens and whispers its findings back to us across a gulf of hundreds of millions of kilometers. Its mission is more than exploration. It is remembrance. Before Juno, we knew Jupiter from a distance, from Voyager's flybys, from Galileo's brief orbit, from telescopes that squinted through Earth's atmosphere. But Juno brought us closer. It reminded us that knowing a planet is not just about facts and measurements. It's about proximity, about returning, again and again, to look from new angles. And with each pass, we understand a little more. The gravitational field tells us where mass lies. The magnetic field tells us how it moves. The cloud patterns tell us where energy flows. And the images, oh, the images, tell us what wonder looks like in pastel turbulence. Juno doesn't just orbit a planet, it orbits a mystery, one that spins faster than any other, with winds faster than sound, with storms older than our civilization, with a heart we cannot yet define. And as it moves, we move with it, not physically, but imaginatively. It draws our attention to a world we've always seen from afar, and it says, look again, look deeper, look longer. In the quiet of space, where Juno flies, there is no applause, no sound at all. But here on Earth, beneath skies Juno will never cross, we listen, we watch, and we thank the tiny spacecraft for helping us see the giant anew. Because in every orbit, every scan, every frame of cloud and storm, Juno reminds us that the universe is not just vast, it is intricate, layered, worth studying, worth listening to, worth visiting, even if only for a while. Jupiter is not only the largest planet in our solar system, it is also the loudest in ways we cannot hear, the brightest in wavelengths we cannot see, and the most magnetic in forces we cannot feel. Surrounding this gas giant is an invisible empire of power, a magnetic field so immense, so commanding, it could swallow the sun twice over and still stretch its arms beyond. It is not just a feature of Jupiter, it is one of its defining acts. Its invisible storm, roaring across space in total silence. This magnetic field, or magnetosphere, isn't just strong, it's staggering. More than 20, 0 times stronger than Earth's. It warps solar wind, bends particles, and sculpts the invisible architecture of the Jovian system. It creates an arena of influence that dwarfs anything we've seen elsewhere. A shield, a trap, a sculptor of auroras, and a cradle of radiation. It is the largest structure of planetary origin in the entire solar system. It begins deep inside Jupiter itself, born not in stone or iron, but in liquid metallic hydrogen, a strange form of matter created by the crushing weight of the planet's own bulk. In Jupiter's depths, where pressures turn atoms into liquid metal, hydrogen flows like a conductive ocean, spinning with the planet's rapid rotation. That movement creates a dynamo, and the dynamo births a field, not a neat bar magnet field like you might picture on a science classroom poster. Jupiter's magnetosphere is complex, lopsided, and ferocious, shaped by fluid motion and asymmetrical layers. As the field reaches outward, it doesn't just stretch, it dominates. It pushes back against the solar wind, the charged stream of particles flowing from the sunday, and carves out a vast bubble in space. This bubble, Jupiter's magnetic domain, is called the magnetosphere. It extends sunward nearly 7 million kilometers, and on the night side, it trails off into an enormous magnetic tail that can reach beyond Saturn's orbit. It is, quite literally, a force of nature, so vast, it could encompass all of Jupiter's moons many times over. Within this magnetic arena, particles are caught, whipped, and accelerated to immense speeds. Radiation belts thicker and harsher than anything Earth has ever known form around the planet, invisible rings of electric fury that would destroy any unprotected spacecraft in minutes. This is a zone not just of magnetism, but of danger, an environment so extreme that shielding spacecraft for survival is a feat of engineering and hope. Galileo, the probe, succumbed to this radiation. Juno, even with its special armor, avoids lingering too long in the most intense regions. And yet, even here, in this hostile and hidden field, there is beauty. At the poles, where the magnetic field plunges into the planet, charged particles crash into Jupiter's upper atmosphere. The collisions excite atoms and molecules, and they emit light. Ghostly curtains of glow that wrap around the poles in brilliant ovals. These are Jupiter's auroras, and they are the brightest in the solar system. Unlike Earth's auroras, which shimmer and fade with solar storms, Jupiter's are nearly constant, pulsing, flickering, whispering. Some auroral pulses are driven by the planet's rapid spin. Others are influenced by the volcanic moon Io, which spews sulfur and oxygen into space. Material that becomes ionized, captured, and swept along magnetic field lines into the planet's atmosphere. It is a dance of matter and magnetism, with moons and storms and magnetospheres all playing parts in a light show we are only beginning to understand. Even more strange, some of the auroras emit in X-rays, a high-energy mystery that still challenges our models. Something about Jupiter turns raw magnetic force into radiation that crosses the electromagnetic spectrum. It is as if the planet itself is not content to be seen only in visible light. It demands to be known in radio waves, in infrared, in ultraviolet, in X-ray flashes flickering across the poles. And Jupiter's magnetosphere doesn't stop at the planet. It shapes the lives of its moons. Io, the most volcanically active world we know, orbits within this field and contributes to it. The plasma torus, an enormous donut-shaped cloud of charged particles, follows Io's path, created by gases ripped from its volcanoes and ionized by the magnetic field. Europa and Ganymede, farther out, move through the field, interacting with it in subtle ways that may reveal their subsurface oceans. Even Ganymede, uniquely among moons, has its own tiny magnetic field, floating like a bubble within the larger Jovian sea of magnetism. It's easy to forget that magnetism is invisible, But on Jupiter, it makes itself known. It speaks in radiation, in storms, in auroras that shimmer in wavelengths we can only see with instruments. It crackles in radio waves so powerful they can be detected by amateur equipment on Earth. Jupiter, murmuring through the dark. This magnetosphere isn't a gentle cocoon. It is a storm, a sculpture, a space-bending dominion that shapes everything around it. It is one of the reasons Jupiter matters so deeply in the architecture of our solar system. It shields, it influences, it commands. Moons orbit within it, particles bend to it, light responds to it, and beneath it all, deep within the giant, liquid metallic hydrogen churns in silence, generating fields that stretch across space like unseen wings. So as you drift, picture it, a giant not just wrapped in clouds and storms, but surrounded by force, an invisible hand extending outward, sweeping up particles, forming belts of fire and rings of light. Jupiter doesn't just spin and shine, it reaches, and what it touches, it changes. In that reach, in that silence, in that invisible storm, there is a kind of music, not one we hear, but one we feel when we learn to look closer. Jupiter's magnetosphere is not only the largest of its kind, it is one of the grandest expressions of motion turned into meaning. And somewhere in that magnetic hush, the giant whispers. In the days before telescopes, before spacecraft and sensors and scientific equations, the sky was a canvas of stories. People looked upward and saw gods, monsters, heroes. Lights that wandered were given names, not numbers, and among them, one shone brighter, slower, more majestic than the rest. It was the planet we now call Jupiter. But to those ancient watchers, it was something more. It was Jupiter, king of the gods, ruler of storms, wielder of thunder, a presence so steady and so luminous that no other name could possibly suit it. The Romans, whose empire stretched across continents, saw divinity in the world's order, and they named the planets to reflect the hierarchy of their pantheon. Closest to the sun was Mercury, the swift messenger, then Venus, the goddess of beauty, then Mars, the god of war. And out beyond them, all was the Great One, massive, radiant, slow-moving, unmissable. That was Jupiter, the god of the sky, the bringer of law, the sovereign whose voice was thunder, and whose will governed both men and gods. Before him, the Greeks had called the same bright wanderer Zeus, and Zeus, too, was a figure of overwhelming presence, a deity of storms and sky, a father figure in both fury and protection. Whether Zeus or Jupiter, the myths echoed each other across cultures, carried by stories, and etched into constellations. These weren't just characters, they were explanations, attempts to make sense of the chaos and order observed in nature, personified in the sky above. And perhaps it's no accident that the largest planet in our solar system bears the name of the most powerful god. Even to the unaided eye, Jupiter is unlike any other. It doesn't twinkle like stars. It gleams, softly but persistently, its light steadier, more anchored. It moves through the constellations slowly, regally, completing its journey around the sun over the course of nearly 12 Earth years. Ancient astronomers tracked it with care. It was too important not to. They noticed its constancy, its size, its refusal to fade like comets or flicker like fainter stars. And so they gave it a name that spoke not only to its presence, but to its imagined personality. Jupiter was more than a celestial body. It was a throne in the heavens, an idea as much as a light. The myths grew from there. Jupiter, the god, ruled from Mount Olympus with a bolt in hand. He kept order, settled disputes, fathered gods and men alike. He was, in many ways, a mirror for power on earth, a divine ideal shaped in the image of earthly kings. But while kings fell and empires shifted, the light of Jupiter remained, unchanged, unmoved by the chaos below. And over time, the stories about gods began to fade, replaced not by disinterest, but by deeper curiosity. Telescopes opened the heavens. Galileo, pointing his handmade device toward that same bright dot, discovered moons circling it. Moons no one had ever seen before, 4 of them, tiny worlds orbiting a larger one. A miniature system, a cosmic court circling a celestial king. In that moment, myth and science didn't collide. They harmonized. The myth gave way to measurement, but the awe remained. We still called it Jupiter. We still remembered why. Even now, the mythology lingers. The spacecraft we send are named in reverence and metaphor. Galileo, the pioneer. Juno, his mythic wife, who could see through the clouds, both metaphorically and literally, as the Juno probe now peers beneath Jupiter's swirling veil. Io, Europa, Ganymede, and Callisto, the Galilean moons, are named for the mortal lovers of Jupiter, each with their own story, their own tragedy, their own role in the divine drama. These names aren't just poetic touches. They're reminders. Reminders that exploration isn't just about data and discovery. It's about wonder, about continuity, about reaching back through time and saying, "We see what you saw, but now we see more." And still, beneath the science, the myth hums. Jupiter, with its massive storms and bands of wind, still feels like a planet of thunder. Its immense gravity, able to shape the orbits of comets and protect the inner solar system, echoes the mythic role of protector and judge. Its radiation belts, invisible and deadly, feel like divine wrath wrapped in magnetism. And its moons, diverse and strange, orbit like a court. Some loyal, some captured, some wandering, but all held in place by the presence of the giant. So as you drift tonight, imagine the sky as it once was, clear, cold, and full of meaning. Imagine a shepherd watching flocks on a hillside thousands of years ago, looking up and seeing a steady light slowly crossing the night. No knowledge of gravity, no equations or spacecraft, just that light, and the feeling that it was important, that it ruled. Imagine that shepherd naming the light Jupiter, and imagining the stories that would follow. And now, imagine us, many centuries later, still watching, still wondering, still naming. We may have traded temples for telescopes, myths for missions, but the impulse is the same: to look up and to listen for the voice of something larger. And sometimes, the universe answers not with thunder, but with light. Above your head, through the veil of city haze or the deep black of rural dark, there's a light that doesn't blink. You might mistake it for a star, but it doesn't twinkle the way stars do. It shines with steadiness, like a thought held long in the mind. On some nights, it's the brightest object in the sky, besides the moon itself, not flickering, not fading, just there, watching, gliding, slow and silent. That light is Jupiter. For thousands of years, humans have followed it with their eyes. Long before anyone knew what it was made of, long before we sent spacecraft to touch its orbit, they watched it drift patiently through the constellations. Not a wanderer lost, but a monarch surveying a kingdom. Even now, its motion across the night sky is slow and graceful. It doesn't race across the heavens like Mercury, nor vanish in phases like Venus. Jupiter takes nearly 12 years to complete a circuit around the Sun. And from Earth, that means watching it inch from one zodiac sign to another over the course of a year or so. Its path is dependable, like a clock too vast to wind down. In the days of ancient Mesopotamia, sky watchers tracked Jupiter's movement on clay tablets. They noticed how it returned to the same part of the sky after long intervals and saw in it a pattern, a rhythm of celestial royalty. The Babylonians gave it a god's name, as did the Greeks, and later the Romans. Cultures, separated by geography and language, looked up and all felt the same thing: reverence. Even without telescopes, they knew this light was different, bigger, closer to the divine. And then came a moment in history when Jupiter stopped being just a myth in motion and became something else. Galileo Galilei, with his crude telescope in 1610, aimed it toward the bright orb and saw something no one else had: 4 tiny stars, close by, moving in ways that defied everything taught by the church and the ancient texts. He watched them night after night, sketching their positions, and he realized the unthinkable. They weren't stars at all. They were moons, orbiting Jupiter, which meant Earth was not the only center of motion in the universe. The heavens, it seemed, had more than one anchor. Those 4 points of light, Io, Europa, Ganymede, and Callisto, would go on to be called the Galilean moons, and their discovery would ripple through science and philosophy like a thunderclap. The idea that Earth was the center of all things, that everything moved around us in divine symmetry, was shaken. It wasn't just a shift in astronomy, it was a shift in how we see ourselves, all because of that steady light in the night. Since then, Jupiter has continued to be a kind of celestial landmark. Amateur astronomers with even a modest pair of binoculars can spot its 4 largest moons dancing around it, sometimes casting shadows on its swirling face. A telescope reveals its cloud bands, maybe even the great red spot if the timing is right. And on some truly clear nights, when Earth is in just the right place, you don't need equipment at all. You just look up, and there it island, big, bold, and serene. It's a strange thing, seeing a planet so clearly. Most of the universe is either too far, too faint, or too fast to grasp. But Jupiter invites you. It doesn't hide in obscurity. It doesn't demand rare conditions or arcane knowledge. It waits in the sky, generous and unmistakable, for anyone with a moment and a neck tilted upward. And in that shared sky, it has become a point of connection. Across centuries and continents, people have stood under its gaze. Philosophers, poets, sailors, and scientists. Farmers checking the skies for omens. Children learning the constellations. Lovers pointing out stars on quiet walks. In each case, Jupiter has been part of the backdrop, part of the unspoken comfort that some things, at least, remain. And yet it changes, slowly but surely. It shifts through opposition and conjunction. Sometimes it vanishes behind the sun for months, only to reappear with a gentle glow in the early morning sky. Its moons eclipse and transit, its storms evolve. But from Earth, the changes are subtle, almost intimate, like watching a friend age across the decades. There's something humbling about that kind of presence. To think that when Galileo looked through his telescope, he saw the same bands of color we see now. When the first star charts were drawn, Jupiter was there, shining over civilizations that no longer exist. And long before that, it was still moving, still glowing, over creatures who had no words for planets or gods or gravity. Just light, just awe. And tonight, if the skies are clear, you can step outside and find it again. Maybe it's hovering just above the horizon, or rising in the east, or hanging high in the midnight dark. And you'll know, without needing a guide or a textbook, that this isn't just a point of light. It's a reminder that we've always looked up, and that the universe, vast and mysterious as it is, sometimes offers us something simple, a bright, beautiful, constant, a planet that taught us to question, a king that challenges dogma, not with force, but with visibility. Jupiter doesn't need to be believed in. It just needs to be seen. Of all the giants that dwell in our solar neighborhood, Jupiter may be the one we owe the most to, though it never demanded thanks. It's often called a protector, a shield, a silent guardian in the cold, dark outskirts of the inner solar system. And tonight, as your body sinks into rest and your thoughts begin to drift beyond the clouds of Earth, we'll wander into a quiet speculation. What if Jupiter hadn't been there at all? It's tempting to imagine a sky still full of stars, a solar system still neatly arranged. But remove Jupiter, and the story begins to unravel in ways both subtle and catastrophic. You see, Jupiter isn't just large, it's foundational. Its gravity, immense and ancient, has shaped the fates of planets, comets, and asteroids for billions of years. At more than twice the mass of all the other planets combined, it doesn't simply orbit the Sunday, it negotiates with it. It bends space in wide arcs, pulling and pushing the debris of creation like a cosmic conductor with invisible hands. In that swirling debris field of the early solar system, Jupiter was both a sculptor and a bouncer. It cleared out vast regions of dangerous material, flinging comets into exile or plunging them into the Sunday. In doing so, it may have saved Earth, again and again, from the kind of devastating collisions that can erase entire chapters of evolution. Some scientists even credit Jupiter with protecting our planet long enough for life to form and flourish. Without it, Earth might still be locked in a cycle of endless bombardment, a cradle too bruised to hold life. And yet, like all forces of gravity, Jupiter's role is more complicated than simple protection. It doesn't just absorb threats, it also stirs the pot. There's evidence that Jupiter may have helped deliver water to Earth in the first place, hurling icy comets from the outer solar system into our dry, rocky world. Imagine that, a colossal planet 400 million miles away, contributing to the oceans that lap our shores, the rivers that carved our canyons, the rain that soaks the earth each spring. A distant giant, shaping the recipe of life with a well-placed nudge. But there's another side to the tale, one where Jupiter, for all its protective prowess, might also be something of a disruptor. Some planetary scientists suggest that its immense gravity may have prevented another Earth-like planet from forming in the asteroid belt. Instead of a sibling world between Mars and Jupiter, we have a broken field of rock and metal forever denied cohesion. And then there's Mars itself, a planet that seems to have stopped growing early, remaining small and dry while Earth blossomed. Was Jupiter's pull responsible for that too? Did it tug too hard or too soon, starving Mars of building blocks before it had the chance to become a lush world of rivers and rain? Even now, Jupiter's influence stretches across time and space. Every 13 months or so, Earth and Jupiter reach what astronomers call opposition, when the giant planet rises as the sun sets, standing opposite in our sky. During these periods, its brightness intensifies, and sometimes it draws near with stories written in light. In 1994, the comet Shoemaker-Levy 9, pulled apart by Jupiter's gravity, smashed into the planet's atmosphere in a cascade of fire and vapor, leaving scars the size of Earth itself. It was a sobering reminder. Jupiter doesn't just guard, it absorbs the blows we might otherwise receive. If Jupiter weren't there to do that, we might be watching different skies, or none at all. Without its gravitational net, Earth would likely face far more frequent cosmic impacts, not just the kind that make a crater in the desert, but the kind that change everything. Climate collapses, mass extinctions, the reset buttons of history. Some scientists even estimate that without Jupiter, Earth would be struck by life-ending impacts dozens or even hundreds of times more often. In that alternate timeline, perhaps no continents ever formed stable life. Perhaps evolution never had the patience to sculpt complex minds. Perhaps we would not be here to dream about distant planets at all. And still, even this idea, this protective, heroic Jupiter, might not be the whole truth. The universe rarely deals in absolutes. Jupiter's influence is chaotic as often as it is calming. In some simulations of early solar systems, giants like Jupiter migrate through their orbits, destabilizing everything in their wake. It's possible that in other star systems, planets like Jupiter have thrown potential Earths into their stars or out into the void. So much depends on timing, on placement, on balance. A guardian, yes, but only if the dance is perfect. Tonight, as we lie back and breathe into the quiet, it's worth pausing to feel the scale of it all. The way one massive sphere, mostly hydrogen and helium, can shape the history of water, fire, and life on a small blue dot millions of kilometers away. The way something so vast can remain silent for eternity and still change everything. We are, in many ways, children of this arrangement, of Earth, of the Sun, and yes, of Jupiter too. Our safety, our stories, our seas, they ripple from its presence. And in the end, perhaps the truth isn't just that we were protected, but that we were noticed, that in the long sweep of cosmic gravity, something ancient was always watching, always pulling, always shaping the path we'd take, from stardust to sentience, a planet that, without ever asking for thanks, gave us the chance to look up and wonder. In the quiet chaos of the early solar system, before the planets found their orbits and before Earth had oceans to cradle life, there was dust and light and the steady pull of gravity shaping everything. Out of that swirl, one presence rose faster and larger than the rest, Jupiter. Not a world like the others, not a sphere of soil and stone, but a giant, born hungry and fast, pulling gas and ice into its arms, becoming the first titan to lay claim to this newborn sky. Jupiter may have been one of the very first planets to form, a silent architect carving lines through a solar system still in its infancy. As the young sun ignited, sending shock waves of radiation outward, the material around it began to condense. Clumps formed in the protoplanetary disk, swirling like dough caught in a whirlpool. And somewhere just beyond the frost line, Jupiter emerged, massive enough to reshape the very possibilities around it. We often think of planets as stationary. Where they are is where they've always been. But in truth, Jupiter may have been a traveler. Some models suggest that this giant didn't begin in the place it now calls home. Instead, it may have migrated, inching inward toward the sun before retreating again, drawn into a complex dance with Saturn and the gravitational tides of the solar disk. This migration, sometimes called the Grand Tack, would have scattered dust and debris like ripples across a pond, disrupting everything in its path. As Jupiter moved, its mass rewrote the fate of nearby worlds. It may have charged through a field of rocky embryos, young, growing planetesimals trying to become something more, and either devoured them or flung them into exile. The inner solar system could have once held more Earths, more Venuses, more hopeful cradles for life, only to have them shattered or starved by the arrival of a hungry giant. And yet, destruction wasn't its only legacy. As it moved, Jupiter sculpted order from chaos. The asteroid belt, a vast region between Mars and Jupiter, was once thought to be the remnant of a planet that never formed, but more likely, it's the echo of Jupiter's passage, a region whose material was stirred, tugged, and never allowed to gather into something whole. Jupiter's gravity prevented cohesion, turned what could have been a world into a field of fragmented memories. At the same time, Jupiter's push and pull may have seeded the inner solar system with building blocks. As it plowed through the early dust and gas, it may have flung material inward, metal-rich rocks and icy fragments, offering Earth the ingredients it needed to become not just solid, but habitable. It may have brought the chaos that made complexity possible. Even today, Jupiter's gravity continues to choreograph this cosmic dance. Its presence maintains the shape of the asteroid belt, holding its edges like a frame around a painting. It traps and shepherds groups of asteroids called Trojans, which trail and lead the planet in its orbit like loyal companions. And it exerts a quiet influence on Saturn, on the outer planets, and even on the long-period comets that drift in from the edges of the Oort cloud. Without Jupiter, the solar system would be a different place. Perhaps more crowded, perhaps more chaotic, or maybe simpler, quieter, less dramatic. It's hard to say. What we do know is that this one giant shaped the flow of everything that followed, like a hand brushing paint across the cosmos, smearing orbits and chances in a single gravitational stroke. There's something poetic about that. That the biggest planet, the one too massive to become anything but a gas giant, is also the one that decided so much about the fates of worlds it would never touch directly. It didn't need to collide or scorch to influence. It only needed to exist, to pull, to orbit, to assert its weight in a system still learning its balance. And in that process, it helped carve out a space for Earth. Not just physically, by keeping the inner planets relatively clear and stable, but metaphorically too. Without Jupiter, there's no guarantee we'd have this solar arrangement at all. No assurance of quiet nights or stable climates or moons that tug at our tides. No guarantee of long enough timelines for life to emerge, adapt, and begin to wonder. Jupiter is not just a planet. It's a gravitational engine, a sculptor of storylines, a silent engineer of planetary fates. It doesn't shimmer with life, and it doesn't glow with heat, but its presence ripples across billions of years and billions of kilometers. When we look up at its bright dot in the night sky, we're not just seeing a planet. We're seeing a shaper of the stage itself. Somewhere in its bands and swirls, in the invisible threads of gravity it casts like nets into space, is a record of our own beginnings, the decisions made before we were born, the paths cleared so that Earth could circle quietly, warmed just enough, distant just enough, to hold oceans and clouds and the quiet breath of sentient thought. Jupiter didn't do this with intention. It doesn't choose or care. But still, it gave. And in giving, it became not just a neighbor, but a kind of unspeaking ancestor, massive, distant, and unknowably old. A giant whose very existence shaped the conditions for curiosity, for wonder, for the quiet act of listening to the night sky and asking, what else is out there? And what forces, long before us, made this fragile moment possible? Jupiter, immense and ancient, still keeps secrets. You can look at its surface for hours, those bands and storms and swirling ochre tapestries, and still know you're only seeing a mask. Its true face lies somewhere beneath the clouds, where pressure builds and light disappears and questions multiply. Even after decades of observation and flybys and mathematical modeling, Jupiter remains a puzzle with missing edges, and in those missing spaces, strange ideas bloom. Some of the phenomena we've caught glimpses of seem almost fictional. There are storms within Jupiter that don't just rage, they glow. These are transient luminous events, bursts of light that flicker deep in the cloud layers, like lightning given a costume. They're rare on Earth, and rarer to observe elsewhere, but Juno and other missions have caught hints of them. Sprites and elves, they're sometimes called. Electric apparitions that dance through the ammonia clouds, too fleeting to study directly, but too bright to ignore. And then there are theories that Jupiter may be surrounded by ghostly rings of plasma, ephemeral, invisible to the eye, but detectable in magnetic data. Not rings like Saturn's, not sculpted ice and dust dancing through sunbeams, but electromagnetic halos, charged particles corralled by the planet's vast magnetic field. These rings would not cast shadows. They would not glimmer. They would hum, faintly, like distant wires vibrating in the wind. Jupiter is a place where thunder might fall not in water but in ammonia, deep within its atmosphere, where the pressure turns gases into liquids and the temperature reaches unearthly levels. It rains chemistry. There may be ammonia snow that sinks into boiling clouds, or water ice colliding with exotic particles, creating flashes of lightning stronger than any we know. It's a storm system with alien rules, a place where the sky does things we can't simulate on Earth. The deeper we look, the stranger it becomes. There's a theory, often whispered in late-night science forums and occasionally explored in serious journals, that gas giants like Jupiter might be failed stars, that they began their lives with the same ingredients, the same gravitational ambition, but simply didn't gather enough mass to ignite. They came close, but not close enough. Their cores grew dense, their atmospheres vast, but their hearts stayed dark. It's true that Jupiter emits more heat than it receives from the Sunday. Not enough to shine, but enough to hint at something smoldering inside. Residual heat from formation, perhaps. Or some internal engine we don't yet fully understand. Some scientists wonder if planets like Jupiter exist on a kind of spectrum, not quite stars, not quite traditional planets, occupying a liminal state between categories, too big to be ignored, too strange to be easily defined. And then there are the anomalies that defy easy categorization, odd shifts in magnetic fields, strange asymmetries in gravity data, flashes of light, and odd emissions in radio frequencies. Even now, with probes looping around it and telescopes watching from afar, Jupiter throws us data we can't neatly explain. It's a laboratory for exotic physics, where hydrogen might become metallic and magnetism might take forms we haven't yet named. There's something deeply humbling about this. We live in a world where data floods our lives, where so much of the physical world is categorized and modeled and understood. And yet, just a few planets away, there's a place we still don't fully grasp. A place where basic questions, what is the core made of? How do the bands form? What causes some storms to last for centuries and others to vanish in weeks, still have no definitive answers. It reminds us that mystery is not a relic of the past. It is alive, drifting in the clouds of Jupiter, flickering in its lightning, humming in the radio emissions that ripple outward like coded messages. Mystery is not something we've outgrown. It is something we return to, again and again, each time a spacecraft sends back a blurry photo or a strange reading. Some even speculate that deep within Jupiter, under immense pressure, hydrogen atoms compress into an exotic metallic state. This liquid metallic hydrogen, if it exists as we think, would conduct electricity like a wire and contribute to the planet's immense magnetic field. But we've never made it on Earth. We've never held it in a lab. It might exist only in the heart of giants, a form of matter that belongs to the deep and the far away. And so, we are left with questions. We chase answers with instruments and models, with equations and infrared eyes. But for every mystery solved, another arises. The deeper we look, the more Jupiter seems to echo back our own limits. It shows us what we don't know. And in doing so, it becomes not just a world, but a mirror, one that reflects the beautiful incompleteness of our knowledge. Jupiter is a world of storms and moons and magnetism, yes, but it is also a keeper of riddles. Its clouds conceal not just chemistry, but possibility. Theories sprout like seeds in its shadow, some wild, some grounded, all pointing to a deeper truth. That even in an age of data and algorithms, some things still resist simplicity. And maybe that's why we keep looking. Because mystery is not the enemy of science. It is the fuel. It's what pulls us toward the telescope. It's what launches the probes. It's what causes someone, somewhere, to stare at a speck of light in the sky and wonder what glows beneath the clouds. Jupiter invites us to imagine more, to accept that not all answers come quickly and not all phenomena fit neatly into categories. It reminds us that the universe is not finished revealing itself. Not yet. Hello again, friend, if you're still with me, still awake, or floating somewhere between the edges of sleep and starlight. Then we've reached the final orbit of our journey. 20 chapters behind us, and one last breath of wonder to share. Together, we've walked among the storms of Jupiter, wandered across frozen moons, swirled through jet streams of ammonia and ice, peered into clouds we can't touch, and listened for whispers beneath surfaces no human foot has ever felt. It's been a voyage not through distance, but through imagination, a soft unfolding of stories, one after the next, like notes on an ancient lullaby drifting out into the void. From the moment we stepped into this story, it was never about facts alone. It was about feeling the scale of something vast, something spinning in silence far beyond our world. It was about sensing, even in the stillness of your room, the magnetic pull of a planet that has shaped the solar system since its earliest days. Jupiter, the monarch of the planets, hasn't just existed. It's ruled, protected, sculpted, disrupted. It's tugged at comets, twisted the fate of moons, maybe even changed the destiny of Earth itself. You've now seen it all, at least, as much as we know. You've stood in the eye of a storm larger than Earth and watched it churn for centuries. You've heard the low thunder of lightning 10 times more powerful than anything we've recorded here. You've watched moons rise and fall in gravitational rhythm, their orbits playing a symphony of timing too perfect to be accidental, and yet born only of nature's elegant chaos. You've passed over Europa's smooth, icy shell and wondered what might swim below. You've felt the fire of Io's restless volcanoes, their lava reshaping the land minute by minute. You've lingered in the shadows of Callisto, quiet and cratered, an ancient sentinel preserving 1 billion years of stories no one's yet heard. You've watched Ganymede glow with its own magnetic field, a moon so large it could almost be a planet, so layered with complexity it already feels like one. We listened to Jupiter's auroras ripple like curtains of electric silk, dancing in magnetism, brighter than anything Earth's sky could dream up. We watched as storms formed and vanished, some brief, others ancient. We studied bands of color, orange and tan and ivory, stretching around the planet in ageless motion, carving and layering Jupiter's face with every new revolution. You floated with the Juno spacecraft, sailing pole to pole, skimming just above the clouds like a bird of metal and math, watching, measuring, sending back portraits that look more like paintings than data. We spoke of the magnetic fields, so powerful they trap radiation like a net, protecting some moons, tormenting others. And we reached into theories that sit on the edge of science. Strange plasmas, flickering sprites, the possibility that Jupiter is not just a planet, but something closer to a star that never woke. And through all of it, you remained here, maybe tucked beneath a blanket, maybe curled on a couch, maybe lying in a dark room, lit only by the soft glow of a screen, somewhere safe, somewhere still, your breath slowing, your thoughts softening, letting the galaxy unfold not through rockets or telescopes, but through sound, story, and stillness. Jupiter was never just a sphere of gas. It was always more than its mass or its orbit or its storms. It was myth, memory, mystery. It was a mirror, reflecting both the grandeur of the cosmos and the gentle hush of night. It showed us that even the giants have layers, that even in chaos there is rhythm, and even in darkness, beauty spins. And now we're here, together, at the final edge of this orbit. So, take a breath, let it out slowly. Let the weight of the day loosen its grip on your shoulders. The planet spins on, moons orbit, auroras shimmer, and you, drifting now in warmth and calm, are part of this universe too. You always were. Good night.